This is AP BC Calculus 2019, question 2. We are given the polar curve r theta, and we are asked to find the area bounded within it, called S. We know that the area for a polar is always 1/2 integral of r theta squared. So we will plug that in for our specific equation, giving us, and plugging this into our calculator gives us the value of 3.534. That is the answer to part A. Now for part B, asks us the average distance from the origin to every point on the polar curve between this interval. Since we know that the average average value of anything is 1 over the distance, which in this case is square root of pi, over the integral of that distance of said function. We'll plug into that formula, giving us this equation, which solves to 1.580. And that is the answer for part B. Part C now asks us to solve for the value of m, which is the slope of the line that divides this region into two equal parts. First, we want to start by thinking what expression has to be met in order for the area covered before this line to be equal to the area after this line. If we know that these two areas are equal, we know that whatever answer we found for A, 1/2 of the area of S must be equal to the integral of the area between 0 and whatever this angle is we're going at. We'll call this theta for now. Of our theta. We pretty much have to solve for this mystery theta angle. And to do that, we'll start with a couple of equations. First, we can relate m to y over x as it is the rise over run. And also we can equate that to tangent of theta as tangent equals opposite over adjacent. And if we imagine this theta angle, the opposite is the y value here, and the adjacent is the x value here. Now that we have that, we can try to solve for m. If we just simply take the arctangent of both sides, we get arctan of m is equal to theta. Now we've found an expression for theta, so we'll just plug this number back into here, giving us the final equation of this expression, which will be our answer. Part D asks a different question where a new equation is added, which is a circle, r equals k cosine of theta. And we're asked to find the area A, which is the portion covered both by the circle and by the area of S. And we're supposed to find that as the k, which is a number here, goes to infinity. Although we can solve this numerically through using some trig equations, the simplest way to think of this is as the circle gets larger and larger, so as we draw more circles here, and eventually the radius k gets infinitely large. So the circle will be large enough to a point where all of the area is covered. So we can we can count the area between the theta equals 0 line and the theta equals pi over 2 line as the circle becomes large enough to fill this entire area, which means all of the area of S between 0 and pi over 2 overlaps with the circle. We can do a very similar thing to part A, where we take the area of a polar graph, again 1/2. This time we use the limit 0 to pi over 2, as we're ignoring this small section to the left. And then we'll do r theta again, and solving for this equation gives us 3.324. which makes sense as the area of S we were given was 3.534. So it makes sense this small sliver makes the numbers like this. Thank you for watching.